Have you ever looked at the Colosseum or the Pantheon in Rome and wondered how these ancient structures have survived for nearly 2,000 years? They've endured earthquakes, wars, and the relentless march of time, while many of our modern buildings start to crumble after just a few decades. What was their secret? The answer lies in an incredible, almost magical material, Roman concrete. Here's the mind-blowing part. It actually gets stronger over time. For centuries, we thought we knew the recipe, but we could never quite replicate its incredible durability. It's been one of history's greatest architectural mysteries. But recently, science has finally cracked the code, and what they found could change the way we build our future. Let's travel back in time. The Romans were master engineers. They built aqueducts that carried water for miles, sprawling cities, and massive amphitheaters. And the backbone of these marvels was their unique concrete, or opus cementitium. Look at the Pantheon in Rome. Its massive, unreinforced concrete dome is still the largest of its kind in the world. Completed way back in 128 AD, then there are the Roman harbors and breakwaters, structures that have been battered by salt water for millennia and are somehow even tougher today than when they were first built. Modern concrete, in contrast, erodes and corrodes when exposed to seawater. A modern concrete pier might last 50 years if we're lucky. So what on earth were the Romans doing differently? For a long time, the accepted theory was that the key ingredient was a special kind of volcanic ash called pozzolana, named after the town of Pozzolana near Mount Vesuvius. The recipe seemed simple enough. Mix this volcanic ash with lime, water, and chunks of rock called aggregate. Scientists analyzed this mixture for decades, but when they tried to recreate it, the results were always disappointing. The modern replicas just didn't have the same staying power. There was clearly a missing piece to the puzzle. The ancient texts from architects like Vitruvius mentioned the ingredients, but they were vague on the exact process. It was like having a list of ingredients for a world-class cake, but no instructions on how to bake it. This is where modern science and a fresh look at old evidence changed everything. For years, when researchers examined samples of Roman concrete, they noticed these tiny, bright white chunks of lime embedded within the material. They were called lime clasts. The prevailing wisdom was that these were just signs of sloppy work. The Romans, they thought, just weren't mixing their concrete thoroughly enough, leaving these unmixed clumps of lime behind. It seemed like a simple case of poor quality control. But a team of scientists from MIT and Harvard thought, what if that wasn't a mistake? What if it was intentional? The Romans were meticulous builders. It seemed unlikely they would be so consistently sloppy across their entire empire for hundreds of years. So they investigated further. Their groundbreaking theory was that the Romans weren't using regular lime, but a more reactive form called quicklime, and they were mixing it in at extremely high temperatures in a process now known as hot mixing. This process would not only create the heat needed for the chemical reactions, but would also leave behind these telltale lime clasts. This was the key that unlocked the secret. These little white chunks weren't a flaw. They were the feature. They were the source of Roman concrete's incredible self-healing ability. Here's how it works. Imagine a tiny crack forming in a Roman concrete wall. It's inevitable. All structures shift and settle over time. Water, like from rain, seeps into this tiny fissure. When this water reaches one of those embedded lime clasts, a chemical reaction kicks off. The lime clast dissolves and then recrystallizes, forming new calcium carbonate structures that spread and fill the crack, essentially gluing the concrete back together from the inside. It's like the concrete has its own built-in immune system, constantly repairing itself whenever it gets damaged. This is why these structures have survived for so long. Every time a small crack appeared, the concrete just healed itself, preventing the small crack from becoming a big, structured, threatening problem. And what about those harbors that get stronger in salt water? The story gets even better. When seawater filters into the concrete, it reacts with the pozzolanic ash and the lime to form incredibly rare and stable minerals like aluminous tobermorite and philipsite. These crystals grow and interlock within the concrete structure, making it even more dense and resistant to fracturing. Modern steel-reinforced concrete, on the other hand, is destroyed by salt water. The chloride ions from the salt penetrate the concrete, corrode the steel rebar inside, which then expands, and cracks the concrete from within. The Romans, by using an unreinforced material that embraced the seawater, created something that worked with nature, not against it. So, if Roman concrete is so amazing, why aren't we using it today? Why don't we just copy the recipe and build everything to last for 2,000 years? Well, there are a few practical reasons. First, the specific volcanic ash the Romans used isn't available everywhere, which would make it expensive to transport globally. Second, Roman concrete cures much slower than our modern Portland cement. In our fast-paced construction world, waiting months for concrete to reach its full strength just isn't feasible for most projects. Modern cement offers high initial strength very quickly, which is essential for today's building schedules. Finally, the hot mixing process itself would require new equipment and safety protocols, since it's a more hazardous process than what we currently use. So, was this a truly lost technology? After the fall of the Roman Empire, the scale of construction plummeted. The complex supply chains needed to get specific volcanic ash to building sites broke down. Knowledge that was once widespread became fragmented and was eventually lost. Simpler, faster, and cheaper building methods took over. So, the knowledge wasn't so much lost in a cataclysm as it was abandoned for convenience. We traded incredible longevity for speed and short-term strength. But the story isn't over. The rediscovery of Roman concrete's secrets is sparking a revolution in materials science. Researchers are now actively working to create a new generation of self-healing concrete inspired by the Roman model. The goal isn't to perfectly replicate the ancient recipe, but to incorporate its principles into modern materials. Imagine concrete that can repair its own cracks, reducing the need for costly maintenance and repairs. This could drastically extend the lifespan of our bridges, tunnels, and buildings. Furthermore, the production of modern Portland cement is a huge source of carbon emissions, accounting for about 8% of the global total. By developing concrete that lasts longer and requires less manufacturing, we could significantly reduce the environmental footprint of the construction industry. This ancient Roman technology could hold the key to a more sustainable future. It's a powerful reminder that sometimes, to innovate and move forward, we need to look back and learn from the incredible wisdom of the past. The Romans weren't just building for their time, they were building for all time. And now, we finally understand how. Thanks for watching. If you found this journey into ancient engineering as fascinating as I did, don't forget to like this video and subscribe for more deep dives into the mysteries of science and history. See you next time.